Hi viewers, welcome to LMS Solution. Today we are going to see about the power system transient stability prediction model using neural network. In power system, right? In power system, the fault it may be occur, right? Because of fault, right? During fault, after cleaning up fault, right? We need to check the stability of the system, whether the system is stable or not. Okay. So based upon that checking, that means status of the power system after clearing the fault, right? So we need to take some control action not to get the continuous power supply to the load, right? And also not avoid the problem in the power system. So for that we need to use some the prediction model. That prediction model when you predict the state, the stability of the system. That system should be in that system stable or not. Okay. So based upon status of that prediction model, so that power plant operator or some automatic control action take the control action in order to uh, secure that power system, and also that can be provide continuous power supply to the customers, right? So for that we need to create some prediction model. So here we are going to use that neural network, so that going to act as a prediction model in order to predict the stability of the power system, that means transient stability of the power system. So here we are using 39 power system. So you can see the detail about 39 power system here, right? So here you can go to this website, right? So in this website you can see the detail of that input system. Okay, this power system, that input system consists of 10 generator. You can see the generator 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it have the 10 buses. And then if you want to know about the more detail about the 10 bus system, so you can use this paper, right? Article in order to get the more detail about that 10 bus system. And also that neural network, right? So that neural network is implemented in the simulating model. Okay, so the 39% simulating model is taken from this website, right? You can go to the network, so you can download that 39% system. So already this author perfect, right? So already developed that 39% system. So I thank other for this other for this wonderful work. So I use this simulating model in order to apply that prediction, neural network prediction model in order to check the transient stability in the 13 system. So I download that one. So I'm using that model. So we can download that 13 system, and then you can apply that concept. Okay. So here you can see that here you are using the neural network. So that neural network having two inputs. So one is rotor speed of the generator, and then another one is mu, nothing but the stability index. So the stability index will be calculated by using this formula. The formula nothing but 360 minus del max. So and then it divided with the 360 plus del max. Okay. So del max nothing but the difference between the power angle, right? Rotor angle between two generators. So you have to take only, that means you have 10 generator, right? You have to take the difference between all generator, right? Power angle difference, and then from that you have to take only maximum value, and then you have to apply this formula. So this formula used for calculating the stability index, and this formula will be provide the detail. It means it should be greater than zero. If is less than zero, maybe the system go for a turn, and that means unstable state. Okay, okay. So yeah, taking two parameter. One is rotor speed, and then stability index, and then label, right? We are making label which is equal to 1 and minus 1. So 1 means we are considered as a stable operation, minus 1 is we are considered as unstable operation. Okay. So for that we are going to create the fault in the system. We are collecting the data before the fault. We are collecting the data after fault. Okay. So after collecting data before after fault, we are making label according with the data. Okay, 1 minus 1. So that data going to be used to train the neural network. Okay. So here you can see that. So here we are using the detail. This data used for collecting the data for different fault conditions. Okay. So we are collecting the speed of the uh, all generator, and then stability index, and then status. So we're going to store the workplace. Okay. So already we collected the data. So I'm going to show the data. Yeah. So here you can see that. So this is the data. Okay. So this is the data input, right? That means rotor speed of the generator, and then stability index, and then here you can say this is the data that means otherwise called label, right? So one means normal operation. So minus one means unstable operation. Stable. One means stable operation. Minus one means unstable operation. So we are collecting the data for different fault conditions and different cases. Okay. And then the data going to be used to for train the neural network. So here I'm going to use and then start, and then I'm going to use splitting app and then click next. So here I'm going to feed the input data first, EE, and then I'm going to feed the second data, that means a label or a target data. It, and then this is going to be used to for train the neural network. So I'm going to train the model, and finally I'm going to use that neural network in the simulating block. Okay. So the same neural network when we used here. So for predicting predict the stable and unstable of the system. Okay. So here I'm going to explain the concept with that I'm going to create the fault, and I'm going to show the detail of the prediction model and the output of the prediction model. So here I'm going to create the fault empty 1 second, and then the fault will be prolonged to the 10 seconds, and then you have to check the stability of the system. So here I'm going to split this model. So here you can see that now the output will be 1, right? System should be stable now. The fault will be occur at 1 second, right? And then after that it will prolong up to 10 cycle. After that it will be create, right? Now we can see that the system, that means status of the neural network, output of neural network is -1. That means it's saying that system now is unstable, right? So that can be seen in the following scope window. So here you can see that the rotor angle is goes more than 360, and also you can see that some generator, that one generator speed is more than 1.1 per right? So system is under unstable condition. Okay. So see, that means the model, a prediction model is predict the status of the system very effectively, and also I'm going to change the fault timing also. So here I'm going to be, that means I'm going to change the fault timing, clearing time, right? Here I'm going to use 5 cycles, right? The fault will be occur at once again, and then it will prolong up to 5 cycles. After that it will be clear, and then you have to check its steps. Okay. Like here once again I'm going to simulate the model, and then check the status from the neural network. So here you can see the status is equal to 1. That means, so here you can see that already the simulation time is around 4 seconds, right? Where getting the status is always 1. That means system having stable operation. So you can see the detail in the scope window, right? Here you can see that after some time the speed and the rotor angle, and that means rotor angle is maintained at the constant, right? At the initial value, right? So now system operating stable condition. Same way I'm going to create the fault in the some other location, and then you have to check the result. So here I'm going to create the fault in this bus, and then you have to check the stability of the system. Now I'm going to create the fault, and then I'm going to simulate the model, and then you have to check the stability of the system. So here the fault will be occur after once again. It prolong up to 5 seconds. After that it will be cleared, and then you have to check the stability of the system, whether the prediction model will provide the status is correct or not. Okay. Now we can see that the status is always 1. That means as for the neural network, the system operate at a stable condition. So we have to check the result of its scope. So here you can see that after some seconds is comes to that the initial value, right? Is it will remain stable, right? The system is operated at a stable condition, right? So next I'm going to little bit I'm going to increase the part the duration to 10 seconds, right? And then you have to check the results. So here you can see that our simulation started. The status will be is 1, right? And then we have to check the result. Now up during fault, right? The rotor angle everything will be changed, right? And then here also you can see that system status will be stable because that rotor angle and the rotor speed is comes to original, right? So system set to be stable for that fault condition also. So and you can see that the result from the neural network are also displayed as one, right? That means it says the system is stable, right? So again, I'm going to change the that means I'm going to change the fault locations, right? That means I'm going to change the fault location to here and then check the system stability. So here I'm going to simulate this model. So here you can see that system now one, right, stable, and also you can see that this variation of rotor angle and the press speed. So this comes to stable, and then we are getting one here from the neural equal to one. That means the prediction neural prediction model saying the system is stable. So here I'm going to increase the halt timing in order to test the stability whether the system is stable or not. The output in the prediction model providing the accurate result or not. Okay. So I increase the fault time to 40 cycles. Okay. And then we have to check the system stability from the neural network. So till now they say system is stable. Now we can see that it indicate -1. That means system is unstable because some of the rotor angle and everything will be open. That we'll check the detail. So now you can see that some of that means the rotor angle, some of the rotor angle goes to some more than 360 degree, and also you can see that the rotor speed is go to more than 1.1 per unit, right? So now you can see that the prediction model telling that that means the system set to be unstable. So saying that neural dot prediction model saying that system is unstable because here you can see that one machine rotor angle is more above that 360, and also you can see that rotor speed of the one machine is beyond that 1.1 per unit, right? So the prediction from the neural network is accurate. Okay. So this power system transient stability prediction model by neural network. Thanks for watching our videos. Kindly subscribe our channel and also the bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye.